Howdy folks, Tom Barbalet here. Just a little notice to say that there were numerous technical difficulties on this recording of Biota Live. We come to this recording about 15 minutes in, having had a number of people get booted off the call and various noise, and the noise was maintained throughout the call. Apologies especially to Gerald de Jong, who comes through really poorly in this recording. However, I'm going to be putting the recording in the feed even though the audio is probably the lowest quality of any of the Biota podcasts to date, which in itself is saying something. So apologies to all who participated in this recording, how poor it was. However, I'm going to put it in there as there was some discussion of interest, I think, for the broader Biota community. In the future, what we're going to do is probably limit the number of callers, which improves the quality of audio no end, and also construct subtopics that can be discussed at various Biota Lives. Apologies once again for the audio quality. However, this week's Biota Live. So, welcome to the Biota podcast, Biota Live. It's a continuation of the Biota podcast. For more information, biota.org/podcast. If you want to call in currently, unfortunately our lines are all full. We've had technical difficulties and various problems, so we're going to have to cycle the calls as it is. However, if you want to get on the call list, 646-200-0640, we will try to get to all the callers on this hour. The next two episodes of Biota Live, Friday, 8 p.m. Pacific, the 28th of March, dropping artificial life into games, the Artificial Life SDK for game development, a topic that was submitted by a listener, Gerald Culler. And the following Saturday, 5th of April, 10 a.m. for East Coast and European listeners in particular, how to create an artificial life startup, a topic of discussion which no doubt will be close to a number of the hearts of the folks on this call who are currently involved in artificial life startups. Some Graytham news. Graytham London. Justin, do you want to give the Graytham London news?
Sure. I mean, we're planning on having one on the 25th. I'm not sure exactly who all is going to be coming, but if there's people that are interested, they could just drop me an email. That'd be great. Or drop one to Tom, actually, and he can forward it over to me, or just drop one to me directly.
Terrific. And it's at the Charlotte Street Hotel, 15 to 17 Charlotte Street, London, which should be relatively easy to find through Google. This coming Graytham in Boston will be hit by a number of Biota CDs. I recorded 20 Biota podcast data CDs last night to send on to Brian to pass out at the next Graytham meeting. Brian, who's going to be speaking at the next Graytham meeting?
Carlos Gershenson, and he'll be speaking on his thesis work in getting self-organizing systems to work. Particularly, the example he's going to use is self-organizing traffic control lights.
Wonderful. And as I mentioned, we had correspondence from a listener, Gerald Culler. Gerald, thank you very much for your correspondence. Unfortunately, we're running a little bit low on time, so I'll talk about the stuff that you've contributed next week with your show topic. For folks listening in, you could get one of 4 books, The Ancestor's Tale by Richard Dawkins, I Was by Steve Wozniak and Gina Smith, Ever Since Darwin by Stephen Jay Gould, and the Oxford Dictionary of Philosophy for submitting a podcast topic. It's that easy. I'm yet to hear from Gerald about exactly which of those books he would like to receive. We did a recording, Brian and I, last Sunday, which will be hitting the feed in the very near future, talking about a wide variety of topics. I had a great degree of fun last Sunday, Brian, and I'm looking forward to passing that audio on to the listeners. There are new mailing lists for Biota. You can get to them by biota.org and look at the link for the mailing lists. There is a podcast mailing list. There is an EvoGrid mailing list, and there is a conversations mailing list if you just want to chat about artificial life-related topics. I'm slowly reworking the Biota.org site. It started actually with a podcast page, so you'll now see a cleaner podcast page if you go to biota.org/podcast. The next page that's going to be worked on is the people page, which has been hopelessly out of date for a number of years now, so look forward to seeing an update. If you would like to call in, the call-in number 646-200-0640. We have two more callers that I'm yet to introduce. Caller number 6, hello. Hello, 6th caller. Is that Bruce by any chance? Okay, I will again go to the 7th caller.
Bruce,
hello, 7th caller.
Bruce Damer back on the line.
Good. So we have a mystery caller who is yet to identify themselves, and I guess they'll come on the call as they do. We now have 7 lines opened up, so I suspect some of them may be duplicates in terms of the call-in. So, the topic this week, slightly belated, the EvoGrid. A lot of stuff's been going on recently. Obviously, Bruce's brief talk to Biota Boston went out in the feed recently. Bruce, would you like to give a recap over the past 3-4 weeks worth of EvoGrid development?
Yeah, the EvoGrid is a concept in development, and there's the mailing list. The EvoGrid mailing list is the place where the discussions are pretty much concentrated. The idea is that maybe the time is now with Web 2.0 and all this new energy and this new resurgence in artificial life systems is to figure out how to create a grid where these different artificial life simulations can interact. And that could take many forms. It could take an early form where a Web 2.0 interface talks to the different simulations and gives you views of all of them. Or it could take a later form where creatures can move around between simulations in the way that Tierra moved between servers, the Tierran creatures move between servers, so that you get a larger effect. And one of the discussions that came out at the Cellar in Cambridge, and then later at the Red Line in Cambridge during the post-Graysum presentation or meetings, was that there's all kinds of fascinating intellectual challenges with it, including scaling. So how do you take a simulation that really is kind of at the bacterial or gene level, gene pool level, and have those entities exist in a Fremsticks type or a Carl Sims blocky creatures type, which is more of the bulk physics level, the larger macro scale. And so there's a scaling challenge. And I know Adam has posted a number of very interesting kind of a taxonomy of different types of artificial life simulations on the list so far, and it probably bears to reproduce those on the site somewhere.
Certainly. I mean, I think we have, aside from yourself, we have 3 contributing callers today in the form of Adam, Brian, and Travis, who all have their particular visions with regards to the EvoGrid. So let's start with Adam. You've posted a lot recently on the mailing list, but for folks not familiar with your vision as posted on the mailing list, can you give some discussion to your ideas with the EvoGrid?
Well, sure. When I met with Bruce and Brian in the Cellar and the Red Line, we discussed the idea of basing the EvoGrid architecture on something open, kind of like the web, and on taking kind of a phased development approach. And what I mean by that is, start simple, start with the idea of creatures communicating, and then go from there to the idea of maybe visualizing the world, and then from there maybe to the idea of migration or richer communication. But what's gone by on the list so far is, first of all, Brian suggested a very web-like metaphor where there really isn't a central server, which I really like because I think it's more feasible and scalable. And then that left us with the question of how to allow, say, a little, single-celled organism, virtual CPU engine like a Vita to talk to organisms in something like Fremsticks or Breve, which at first, seemed kind of like an intractable problem. One of the approaches that I recently posted to the list that I think might be kind of interesting is to implement kind of a common message passing metaphor, where creatures of different scales can pass messages of different sizes, and then to use a scaling algorithm kind of analogous to the scaling algorithms that you use in image editing programs to actually scale the messages back and forth. So to give a concrete analogy, imagine if I meet an alien from a four-dimensional world. Well, I can never go to his world and he can't come to mine, but if he had some technology that enabled him to down project himself into 3 dimensions, and I had some technology that enabled me to up project myself into 4 dimensions by basically doing scaling, then we would look really funny to each other, but we could, over a period of essentially co-evolutionary learning, learn to communicate. And so that was one thing that's gone by on the list. And then I know Bruce is discussing the idea of migration, or how could creatures actually travel between simulations, and also the idea of how, okay, if you've got a communication metaphor going, how can creatures actually then be visualized at a higher level by something like a browser?
Certainly. If we can talk a little bit about the idea of size, I'm not sure, Gerald, in your Darwin at Home development, do you have some description of size associated with your forms?
They have, they exist in 3 dimensions, and I just have numbers representing the size. It's nothing. I have trouble imagining how they would be interacting with something like a 2-dimensional creature, or that. I don't see like scaling working across, dimensions. You can't put something 3-dimensional into 2 dimensions. You can look at it and turn it into a 2-dimensional image, and that might be enough. But I can't see. What kind of interaction are we talking about here?
I think we're talking about message passing. So I'm not so much thinking about the size of the organisms in their native environment, because that's, of course, totally implementation dependent and even kind of relative. What I'm talking about is the idea that I could get a message to a completely different universe. And the idea is that scaling would, in fact, be lossy, especially if you were going from a big organism to a small. So let's say you had something like a creature in Framsticks that has a neural net brain that creates, messages that I don't know exactly what its architecture is, but let's speculate that they're 16 by 16 2-dimensional grids of integers. And then you have another world where the organisms accept messages in the form of 1-dimensional vectors of 8 integers. Well, in that case, you just scale it, and you do lose information in the scaling. It is lossy, but the idea is that some repertoire could evolve between those 2 creatures given a common scaling algorithm where they could communicate or interact in some way.
In that system, however, certainly what I've done with Noble Ape in terms of expanding areas, the Noble Apes would be extraordinarily small with reference to smaller simulation spaces. I mean, I think the challenge with regards to looking at existing simulation spaces as a means of scaling is that you want, if you create some kind of shared simulation space, really to give a next generation element to it to encourage people to move across to it as well. So, for example, in the case of what I've been doing with Noble Ape and what Gerald has been talking about with Darwin at Home, the idea of a large sphere comes through both of our developments. So if you could create the EvoGrid on a large sphere and then create protocols for communication, I think the scaling question is one that will come up repeatedly until there is a fixed environment example or a shared environment example. Now, I know Brian and perhaps Adam, I'm not sure the general thinking, but there was some discussion with regards to actually having closed areas like 3-dimensional areas with particular physics, 2-dimensional areas with particular physics, and then some interface of communication. Was that Brian's idea or Adam's idea primarily?
That I was my idea that came out of the discussion at the cellar. And just before tackling down, I just want to say something about sharing information between different simulations of different scale. I think one of the ways to envision how things could work, say you had something like Tierra or Nanopond, the results of that simulation could be used in lots of different ways in other worlds, where maybe you take the percentage of some type of quote creature and have that affect some variable like salinity or temperature, or if you have a grid, maybe you can make that affect soil quality or something like that if you have something that where food is being generated. So there's lots of different ways you can take something that really doesn't seem to have a natural fit or natural scale mapping to another world and use it for a completely different purpose. So I just wanted to comment that when we think of these things, you don't necessarily have to be mapping something that's, 1/10,000th of a meter next to something that's, 2 meters big. I mean, you can really combine these worlds in different ways depending on what sort of dynamics you want to get out of them.
I think my point was more of the fashion that obviously in the scales of the systems that we're describing, particularly the kind of petri dish simulation environments, which ultimately Noble Ape is one of those simulations as well. It's only a toroidal continuous petri dish in some regard. But if you keep them all in the same simulation environments, the communication, particularly with regards to scale, but as you say, also with regards to meaningful information, is going to be problematic. I thought initially in the discussion, I think this talks a little bit about the idea of separate boundary areas of a shared simulation environment, one multidimensional, one with energy characteristics, these kind of things, lends itself to actually taking the agents from these simulation environments, be they Noble Apes or Gerald's forms or Jeffrey's, swimming creatures, and putting them in a shared environment. Now, can you talk a little bit about this, Brian, with regards to your idea of multi-dimensional, multi-energy states over a shared environment?
Sure. Yeah, so that idea is each simulation can know what kind of data it can process. So it will need certain tags. So if, say, you have 3D physically simulated creatures, you might need to have objects that satisfy a couple of these different tags. So you need to get physical information on its size, you need to get information on its mobility, and that kind of stuff. But the creature that's coming across could also have extra data. For instance, it might have some sort of electromagnetic state or a temperature state or something like that contained in its data. But your simulation might not need that, so it'll just throw it out. So there'll be a system of tags, at least as it was, as the idea was developed, that each simulation says, I need these certain things, or if I don't get, these, I can use default values. But these are the primary sets, and that way simulations can know what kind of data it can receive.
Are you talking about an XML protocol? Is this what you're thinking about, XML?
We used XML as the example just because, the actual data format that's used, I think, is irrelevant. But XML at least gives a convenient way to think about it. And it's something that's, it's a widely used standard. There might be issues in terms of we might want a binary standard or binary format, rather, or something like that. But yeah, as it was envisioned, we were talking about XML.
One point that I kind of wanted to make, just to kind of you feel like maybe something wasn't quite gotten across, is the idea that, like, okay, on the web, you don't have like all computers running the same operating system. And the reason for that is that really all operating systems stink. They just stink in different ways. So the idea of the web is, instead of trying to get everybody to build on the same platform or with the same tools or in the same language or the same operating system, you just get everybody to speak a common open protocol. And I think that's what we're kind of gravitating toward here.
Absolutely.
Yeah, I think that's exactly right, Adam. This is Travis. In my mind, the whole idea that we're kind of gravitating towards is building that basic building block for communicating artificial life and defining artificial life. And certainly kind of the idea here is that a lot of that can be very abstract when you just get down to the very nugget of what's really there, which is just kind of an n-dimensional array of data.
So in terms of moving kind of high-level abstract ideas as we're discussing currently through implementation and back to artificial life developers, I know, Adam, you had some posts in the list with regards to the practicalities of implementation. Do you want to talk a little bit about that?
Sure. Actually, one thing that I was going to do, I was planning to do already, was an open source transport library enabling people to connect even if they're both behind firewalls. And I was going to do this anyway because I was going to use it for a couple of other projects I'm involved in. So first of all, that would enable people, different EvoGrid environments, to reach each other regardless of where they are on the network. So, you know, things like screensavers, that sort of thing. But in a more sort of artificial life-centric area, I was thinking of starting with something like, okay, we have a common protocol, maybe based on XML at first, and then maybe eventually progressing to something more efficient, like Brian said, where what we try to do is we try to just take a couple of different kinds of A-Life systems and link them together and write some kind of common scaling or translation algorithm that causes them to be able to interact in some way, and basically start there. And I think that there's a risk with a project like this because what we're trying to do is like the web. When they originally designed the web, they didn't start by designing JavaScript and Ajax and JSON and REST and Ruby on Rails. They started by designing HTML and document stores and HTTP. So what we're, I think, gravitating toward is the idea of starting with just a basic general protocol with some kind of basic, you know, repertoire of translation algorithms that enable us to connect different A-Life systems that formerly could not communicate and just get them talking. And the model that I suggested was they speak in n-dimensional arrays of data. They send data in their own native size and dimensionality, and when they arrive at the destination, the programmer, the author of the framework that that's trying to be connected, just writes a little rule that says how that data should be down projected or up projected or translated or whatever. So, you know, it would be somewhat implementation dependent.
Can I ask a question here?
Sure.
I was wondering, I've heard now twice the idea of that somehow everything is captured in an n-dimensional array. What's this about?
Well, consider, for instance, you know, organisms in a 3D environment, and imagine that they can see. Well, vision is essentially a two-dimensional array of RGB values. And then consider little guys in a Tierra-like environment that can pass little integers back and forth to each other. Well, those are basically one-dimensional single values. So the idea is that this is just a common way of looking at data. Or take, for instance, an audio stream. An audio stream is a one-dimensional vector of values, you know. So the idea is you can take pretty much any kind of sensory motor data that A-Life systems generate, and you could translate it into this as kind of a lowest common denominator.
But surely that would require the receiving A-Life system to be able to translate what could be quite complicated and quite large data in a meaningful way. I mean, I think
yes.
My own reflection in the kind of artificial life simulations that create even relatively high-level abstract data is that they always do some degree of interpolation. I mean, the important part is the meaningful information as opposed to just sending, you know, vision information ad nauseum. And I think the interesting part of this problem is you want to create a subset of data that is useful. In my recent tinkering, I'm not sure if you've seen on the posts with regards to the Noble Ape phenotype XML, an idea of what the meaningful communication with regards to a particular renderer would be in terms of the Noble Ape states, their energy states, their age, basic descriptions of the Noble Apes as an observer looking at the simulation would see. And I think it's an interesting problem to start looking at that observable phenotype component of what we're all doing as being the ideal information to be transmitting as opposed to raw sound or raw rendered images or these kind of things. I know.
even an XML or whatever representation of one of the Darwin drum creatures, that's a significant size of message to pass back and forth, because there's a huge amount of information with regards to state, and to have a realistic representation of it, it'd have to be moving quite quickly. So that's a huge firepower of information, really, coded in messages.
So, Adam, what's your particular thinking on this?
Well, my thinking so far is that, and there's obviously a lot of unanswered questions here, and that's why we're having an ongoing discussion. But my thinking so far is, if you can get them to talk, and if you can take incoming data and translate it into something that can even be plugged in to an organism at the receiving end, then you could set up some kind of co-evolutionary game or co-evolutionary environment that would reward maybe game playing or cooperation between both ends, so as to basically use evolution to develop a communication repertoire. I mean, let me give you an analogy. Imagine that, again, my four-dimensional alien appears to me, and I start talking to him, or no, I don't start talking to him, because when he appears to me, he sounds like noise and he looks like almost like TV static. But in the course of trying to make gestures at this weird blob that's appeared in my room, some food or some gold appears, and then I figure out that I'm doing some kind of game with this thing, and then I have an incentive to try to apply the pattern recognition skills of my brain and see if I can see any patterns in this noise. And the idea is, maybe eventually, evolution, of course, is a form of learning, maybe eventually the receiving A-life systems will evolve a native proficiency for deciphering the messages from the senders. That's one view that I currently have as to how this could work, and I'd like to hear actually what everyone else thinks about this.
Well, if I may, this is Travis again. One of the things that I like about the idea is that it gives kind of my programs a way to talk to each other. So just forgetting for just 1 second that this is in truly a cross-platform protocol, or cross bioorganism protocol, I should say. It gives my bioorganisms a way to internally communicate, and it gives them a way to communicate that is abstract, at least from what we're talking about, of the actual transport. And so if it's as simple as they're writing files to a hard disk and then those are being served on a web server, well, this would be much more like RSS, right? And then discovery can happen through Google, for instance, or I search for these biocasts or whatever things are being served off of these web servers that conform to this standard that are in fact of my bio world. So I can exclude. I don't have to be talking to everything. I don't have to use this for everything. The other thing that I wanted to mention is that evolution is definitely more clever than we are. And when you set up kind of in a more abstract environment, one that doesn't necessarily conform to the rules of physics, but more conforms to the rules of the landscape that's projected upon it, where the landscape that's projected upon it is literally a function of the stimuli or the message in this case. Different rules can evolve out of that environment. Ones that certainly we're not expecting, and ones that I've seen evolve out of there I wasn't expecting. So I think it's a little early to just dismiss it as being, well, they're not going to understand each other. They're not going to be able to understand what the other one looks like and is saying, and it doesn't make sense because they're not interpolating these pieces of data correctly. I think that when these emergent behaviors really do start to form in these more complex systems, I think that there is a possibility for cross biodiversity between bioorganisms.
Can I ask you a question, Travis?
Yes, please.
To keep this to a relatively lower level, although I'm sure our non-technical listeners have already probably tuned out by now, the RSS feed example is very interesting, and I think this speaks to what Gerald is saying and one of my concerns as well with regards to RSS. For example, this podcast is transmitted to a number of folk through an RSS feed. It's updated weekly, occasionally slightly more. Websites similarly of the blogs that I read frequently, most of them are updated at the most probably 8 times a day, and even that is extreme. The kind of simulation that we typically do, things develop within, fractions of a second to seconds. And transmitting this kind of information in real time through an RSS-like format doesn't seem to be relatively pertinent to simulators such as Gerald and myself. Another interesting point about the RSS idea is that, and I'm not totally clear with regards to Darwin at Home, but certainly with regards to Noble Ape, when I've done tests over distributed systems with regards to Noble Ape, I've found that certain parts of the simulation environment can be run autonomously just with a pulse in terms of updating information. The external world in the Noble Ape simulation is fundamentally like that. And I can see things that are updated in a way which can be done uniformly across a network are no-brainers. In fact, my dream with regards to the EvoGrid is the shared simulation environment is like that. But in terms of the actual organism interaction, there is a degree of communication which is required, which is far faster than what we've traditionally talked about with regards to RSS or web standards. In terms of the description that you've given with regards to evolutionary methodology associated with this, can you talk a little bit more about this time and discrepancy?
Sure, certainly, because part of the beauty of this particular protocol is that the transport is abstract. It doesn't have to be the web. I'm very much envisioning the scenario where an organism wants to connect with its neighbors, and so it goes onto Google and tries to do some discovery. It searches for, its neighbors. It searches for other organisms of its type, and it comes across their feeds, and so it connects to their feeds and downloads their feeds, and their feeds consist of messages which tell it how to interconnect with it, right? So at that point, now they can talk live. Maybe they're using Atom's NAT punch-through technology, right, or some other technology to connect through their NAT or their firewall. But the whole point is that at any layer higher or at any layer lower, we can add additional information. So any layer higher would be like we're adding discovery via Google, and any layer lower would be like within the messages themselves, we're adding our IP addresses, which you can in turn connect to these individual organisms, for instance, if that's what the standard defines. Or maybe that's not what the standard defines, maybe that's what the messages are defining. And when we interpret those messages, that's what we discover is, hey, now we can go connect to our neighbors in more of a real-time protocol.
What I want to really look out for is defining protocols that limit what people can do in general. And if you talk about artificial life features that are exchanging messages with each other, that's one very specific kind of artificial life. It's like a chatty agent trying to discover how to communicate with other chatty agents. But that's so different from different kinds of artificial life. Like, I can't see. You got to watch out that you don't limit it to a certain kind by defining the protocol.
Well, you can also treat this as more of like a gene bank, right? Take the Wayback Machine, which archives web pages, right? Well, what if you had a gene bank for archiving your snapshots of your evolution, right? And this was a way that you could publish that information such that it could be archived and indexed and even replayed later in your own simulation.
Travis, I believe that's what Gerald is doing with Darwin at Home. I believe there's a component of Darwin at Home that explicitly does that currently.
Yeah, that makes sense. To that point, it makes sense. And I'm thinking, if you're going to have communication among, wholly different, artificial life simulations, there has to be something that they actually share. And to me, one good candidate would be space. If they're able to somehow share positions in space and have the ability to communicate based on proximity in space, that's at least something that they would share. But, once again, that might be limiting it to the kind of virtual world that I'm thinking about, the kind of artificial life that I'm on.
Well, in my simulations, I've definitely noticed that emergence behavior very large impact on the evolutionary process. and that emergent behavior really out of as a result of the interaction in the environment. Both they're breathing on their microphone.
So I have a slightly high-level question that comes out of this because there's time running short in some regard. We have Bruce, we have Justin, and we have Brian on the line, and each of these people, in the case of Justin and Brian, and I guess Adam as well, have primary connections with grey thumb groups, and in the case of Bruce, he actively goes and evangelizes the EvoGrid as well. I'd like to start with Justin because his Grey Thumb London is coming up in the near future. What takeaway information for artificial life developers will you give your Grey Thumb currently, Justin, with regards to the EvoGrid development?
Okay. Well, that's I think it sounds to me that it's pretty interesting. I think that some of my takeaways are, one, what we're doing is very low level in the sense that it's not like writing a new scripting language. It's actually at the transport layer of communication, and as such is critically important and more similar to the work that was done in the 60s and 70s when they developed the internet. And two, I think that one of the key takeaways that I have personally is that evolutionary computation is much further advanced than most people give it credit for. So I think that there are currently significant applications for these technologies, whether it's Noble Ape, whether it's the AutoCore stuff that Adam's written, whether it's the stuff that Travis has done, whether it's the stuff that Gerald has done, Jeffrey's work, your own work. I mean, all these different people have created quite interesting applications that have tremendous commercial application, as well as academic and research applications. And I think that there needs to be a more significant interest from programmers who are doing things the old way. They need to start, as Adam is so fond of saying, they need to start growing algorithms. So my takeaways is it's not science fiction, it's today. It's just not widely distributed yet.
So, Brian, what will you take back to this coming month's Grey Thumb meeting with regards to the EvoGrid development?
Well, I guess the big question I have, and what I'd like to find out more from the Grey Thumb community, is about what is it that the community members would really like to share, or how would they like to collaborate with other A-Life developers. And one of the things we've learned with Grey Thumb is that a lot of the people who go there are very curious and would like to play around with things, but aren't necessarily die-hard developers. So the question I have is, what kind of software would you like to be able to download so that you can exchange some sort of meaningful information with some of your peers who are either in the meeting room right there, or who are perhaps overseas, and just try to get that information? Because the one big issue I have with all of these systems connecting is what sort of collaboration between A-Life simulations do people want? What hole is this filling where do people want to see neat creatures coming into their world, or do people want to see do they want to see their creatures going across the planet, going to other people's computers? The big question I have is, how do people want to share? And so the big take-back, I guess you could say, that I have is just finding out from the community what sort of vision would they have of something exciting that they could collaborate with others on.
And certainly as I sit here, I'm looking at the box of CDs I'm going to be sending you. I mean, I think through the Grey Thumb Boston and Grey Thumb London meetings, the real point with regards to this EvoGrid development and a number of the other Biota things, including this podcast, is that we're looking for a community contribution in terms of community interest and community feedback. So, I mean, obviously with the EvoGrid mailing list is the way to go, and we have other mailing lists set up for other general Biota discussions. So, Bruce, the idea of the EvoGrid seems to be evolving as its own kind of idea and moving in many different directions. As the kind of originator and in some cases the ringmaster of the idea, how do you see communicating the changes in the EvoGrid in the near future?
I think that what we need to do is somehow create a thread on, there is a beginning EvoGrid wiki within the Biota wiki, and we need to somehow capture these salient ideas and capture the evolution of the idea so that we're all in a common mental model. I think that may be a next need for this concept.
Yes, I think it's a fascinating idea, and the changes in the idea as are being captured in this podcast and the EvoGrid mailing list, and as you say, the EvoGrid wiki components on the Biota site are all ways that people can contribute and get involved. And I think certainly from what Adam has talked about, from what Travis has talked about, from Brian talked about, and Gerald's feedback as well, I think there are a number of different ideas, a number of problems, but a kind of shared vision. A question back to you, Bruce, with regards to this. If there is a situation where some existing artificial life environments cannot explicitly contribute to the EvoGrid development, obviously the developers themselves should be active participants as well. From what Gerald has talked about today in terms of his own concerns, it is foreseeable that there may be some existing artificial life environments that can't actually interact with the EvoGrid. What's your thinking with regards to that?
I think that's completely correct, and that there may be goals like morphological evolution for a very specific, tuned artificial life environment that really can't gain anything from being part of some kind of an EvoGrid. And I love Travis's vision, if that was Travis's vision, of these kind of open plastic EvoGrid sims that will reach out and use Google as a search engine to find things. That's almost like a semantic type artificial life versus a high-performance physics kind of artificial life that needs to have full encapsulation. So I think there's really a flavor here. Things that are EvoGrid ready or EvoGrid destined tend to be maybe a little bit more horizontal looking than more vertical looking.
Does that resonate with your own thinking, Gerald, with regards to this development?
Well, what I'm thinking right now is that if we could just divide it up into, or put things on a spectrum between space and time. What do you think of that? I mean, if you have, artificial life creatures that actually do their stuff by communicating with each other in time via some sort of messaging protocol, and it's all about synchronization, it's all about network communication and whatever else. And on the other end of the spectrum, you've got artificial life that's busy with space instead. Like you've got the swimmers of jumping in or my running creatures, or some perhaps noble ages, a mixture of those two in some regard. But I think you've got a scale sort of between space and time, and the spatial ones are going to have to live in their own special environment where calculations are going to have speed, and there's a visualization. And of course, there's the other end of the scale where you've got sort of relatively slow artificial life communicating along on a network. Very different creatures. And what would be nice is if one could sort of occupy the other. I'm thinking still in terms of this sort of mind-body duality. Have you thought about that yet, Tom?
Yeah, I think it raises a number of interesting questions, and as people have noted, I think this call has in itself evolved into an EvoGrid as the kind of noise and fluctuations go through it. So what I might do is I might round up the Biota Live a little early, just so we can kind of go away and think about this. I certainly think in coming months what we will do is have selective Biota Lives where a few of us can contribute. I think we have 8 people on this call currently, which has probably broken the Blog Talk Radio system in some regard. So what I think we should do is probably work out a plan for after the next 2 Biota Lives to have some walkout in terms of the ideas that we've discussed into a kind of fuller environmental discussion with regards to the EvoGrid. I think particularly in terms of what Brian was saying, in terms of getting the broader Grey Thumb communities communicating, and also other folks that are listening to this podcast and reflecting on their ability to communicate as well. And I think probably we need to organize it in a fashion where there are maybe 3 or 4 of us on the call and the potential for a couple of additional people to call in, because I think we've reached the extreme of the technology today. So in kind of wrapping up a little early, I think I probably should go through each of you and give you a chance to have a minute to talk about your current developments. Obviously, Justin, you have a Grey Thumb London coming up in the near future. In addition to you, are there other folk that are forming a kind of core group of Grey Thumb London, or are you pretty well running the show currently?
I don't even think I'm going to be at the Grey Thumb London this week unless I can change my schedule. I think it's not really necessarily me anymore. I mean, we had at the last Grey Thumb, we had a bunch of academics that I had never met before that have been following the podcast, and one of them is named Tatiana, a Russian student who's doing some information gathering or work on intelligent agents. The gentleman that was there from some investment banking firm. So those guys, another student from, I think, Surrey. And so they've actually been kind of sending emails back and forth and driving it forward more than myself. I think Gerald will be talking at the next via Skype. And then I think Tatiana is going to give a little bit of a talk. Maybe Nick and maybe this guy from Surrey is also going to give a talk. So I'm trying to basically fade away into the background and let the rest of the community pick it up and run it forward.
And are these people communicating with Brian and Adam and co in Boston as well?
No, most of them are just dropping me an email. It'd be good if Brian or Adam could jump into the conversation. That'd be lovely. I mean, I think the key here, or even some of the other Grey Thumbers like John Klein or some of the other ones. No, these are just individual students. They're at the University of Surrey. They're here in London. Some of them work for corporations. We actually had an editor from the Operational Research Society that was there, who was very excited about what we were doing and actually wants some of the Grey Thumb people to contribute to the Operational Society's, the Operational Research Society's newsletter that they have. So we had a nice selection of people, and I think the key thing for me, from my perspective, is that I may have tried to trigger or catalyze the start of Grey Thumb London, but it's actually very important that the community kind of steps in and other people move to the forward and actually take over and make sure that this continues and has some momentum beyond just myself. And I've already seen that happening just in terms of the emails that I'm getting from these people. I actually am having a hard time keeping up with them.
Terrific. Do you need a mailing list for this by any chance?
That would be absolutely great if we could do that.
Okay, I'll set one up for you. So, Travis, in terms of the inspiration associated with these Grey Thumb movements, I know you're based in LA. Would you consider starting up at a Grey Thumb LA?
Absolutely, I'd love to.
So I think this is, in fact, in some regard, motivating the discussion that I had with Brian last Sunday, which hopefully will be going out sometime in the next couple of days. Brian, in terms of the organization associated with Grey Thumbs, what's your vision with regards to the kind of short-term community development with the potential of a Silicon Valley in LA and a London chapter starting up?
Well, we're excited about it. Our big interest is just finding all the people who are out there who have an interest in A-Life and getting discussion moving around between these people. So, anywhere where there are people who are interested in A-Life, we'd love to see groups forming up where people have a forum to discuss either projects that they're working on or projects that they find inspiring or interesting. So it's very exciting for all of us. And one of the issues we're working on is just sort of what type of organizations or what type of communication do we have between these groups. And so that's something that we're continually brainstorming on and looking for feedback from the community.
Terrific. And Adam, I know you, Travis, and I are going to be doing a Biota chat in the near future in terms of your continued development. I know you can't really talk a lot about what you're working on currently, but I think in terms of broader chats, Travis and I are going to be talking about the ethics of artificial life. Aside from the technical aspects of artificial life, what are your broader kind of meta-interests with artificial life?
Well, I see sort of a long-term effort, and it is definitely a long-term and very difficult effort of trying to make what I kind of see as the next step in the evolution of software development, where we don't flip switches anymore on main boards and enter source code manually. Now we actually use compiled languages and everything else, and I see evolutionary computation and the ability to actually synthesize software and designs using evolution as being sort of the next logical step on that. In the immediate future, I'm hoping to contribute to the EvoGrid project, especially since some of the transport layer stuff for the EvoGrid project actually dovetails with other things I happen to be working on right at the moment. And then in the long term, I'm hoping that the EvoGrid project could catalyze progress in evolutionary computation in the same way that the web has catalyzed progress in general software engineering and human communication.
Certainly. Well, unfortunately, we're out of time. Gerald, I know you're going to be talking at Grace on London, and Bruce, it's been great fun as always. Thank you all very much for tuning in, and the next Biota Live will be 8 p.m. Pacific this Friday when we discuss the Artificial Life SDK. Thank you all very much.